Hi, in this demonstration I'm going to show how to use gener8 Studio to replicate a function block routine. So gener8 can actually be used on kind of about everything you can export from RSLogix or Studio 5000. But in this demonstration I'll do it with a function block routine. So let's go here to my RSLogix. This is RSLogix 5000 version 20. So you can actually export from any RSLogix which supports exporting to L5X. I think it starts from version 17 if I'm not mistaken. So just about this, what we're having here, to give a bit of understanding, it's an analog input processing block. So here there's an analog input that's hooked up through a normal scale instruction. This is an add-on instruction. So gener8 Studio supports add-on instructions, UDTs, anything that's exportable from RSLogix, it supports that. Here are some standard built-in alarm instructions: an analog alarm instruction, digital alarm instruction, and some signal fault tags that comes with together with this analog input. It's a hard analog input module, and this model's got some nice diagnostics, like for example it's got a broken wire detection and so on. Here is another tag that's just a normal memory tag, which is something I normally use with a get system value to detect whether my module is actually online or whether there's a fault, and that way I can generate a fault bit which goes into this block to notify the user that there's something wrong with the signal. So together with this block here, I've got some UDTs that goes with it. There's a data structure. It's a normal UDT. If you look here in the controller organizer on the side, here you see analog input data. This is what we're having here, and then I'm referring the two alarms in, and there is another area which is a UDT, which is this area summary data. It's just a UDT where several of these instructions can actually just summarize what's going on in that area. So this is a normal add-on instruction. It can be anything. It can be function blocks, it can be ladder logic, it can be structured text. This one in this case is ladder logic, so I can open the instruction logic, and here you see normal ladder logic on the inside. Let's go back here. So now I have to start to parameterize this routine here. So I'm going to start the normal way with my controller tags. So all of this, in this case, I'm storing it in my controller tags. It could be stored program scope tags as well. Just in this example, I have it as controller scope. So go on edit tags and say search replace, and I'm going to search for whatever I used as a common name here. Let's say this PI 21005. I'm going to call it p tag name p. So again, parameters always prefixed by p underscore and postfixed by an underscore p, and in that way gener8 will pick it up as a parameter to replace all. And let's just rename this tag to p mod fault p, something like that, module fault. And let's rename this area summary to p area p. I give it a description p area description p, something like that. Module fault, we can also give a description. No, let's do module. Let's do the same as the name. Fault. This can be anything you like, obviously. Okay, and then I'm gonna find replace the description. So let me go here. It's important when you do this. Try doing it in current tags, otherwise it might replace things that you're not aware of. So I normally just select current tags here and Now I'm going to do the description, and let's call this P, description P. Okay, and there we go. So now all the controller scope tags are done. You can check the program scope tags, but in this case we don't have any. Okay, let's rename this routine. I'm also going to call it P tag name P. Then the routine name will be exactly the same as the base tag name that I'm using here. And the description P. P description P. Okay, let's go back to the routine, and here we can see all the tags are renamed. Now in this UDT here, we have a bit of string data. So to get to that, an easy way is just going to the properties and expanding here. So here I can see some string data that I also would like to have parameterized. I would like to, instead of using the tag name with underscores, I would like to have a little something that's a bit easier on the eye. So let's call it P name P instead of P tag name P. Make it a separate parameter, then we can assign something different to that. The description can be the same, and we have some units, process variable unit. Let's see, P unit PV P, and this is the raw input signal P raw. Let's take unit raw P unit raw P. Okay, so then these will also be picked up as parameters. Anything with a P, starting with a P underscore and ending with an underscore P, that's gener8 will pick it up as a parameter. Okay, now these input signals here, let's create parameters for the rack, the slot and the channel, instead of having to create something in Excel that builds this whole string. I'm going to just create it into several parameters. So let's make the local a P, rack P, and this we can do a P slot P, and the channel 0 P channel P, just like in the same string. And then this is actually the same for all of these signals up to the channel. So I'm just gonna copy this, Control C, and I'm gonna Control V it in here. So it's complaining now that it's invalid, but that's fine. We'll replace it with valid data inside gener8 Studio. Okay, then let's have a look at the alarm instructions. There's not much we can do here. I can't change the limits. I can't put parameters in here. I can't put parameters in the tick boxes, obviously, but there's a way of doing that in gener8 Studio itself. So the messages here, these are actually made up from past data. The string tags you saw in here in this referred UDT, they are actually being used to build a dynamic alarm message in this case. So those are fine, but elsewise I could have inserted some parameters here as well. The factory view command, I would like to do something here. I would like to use it in factory view. If I double click on the alarm, it should trigger this command and open the display where I'm actually placing the graphic for this analog input. So let's put a P display P in here. So it will display in whatever display I'm passing through as a parameter. And I want to do the same on this digital alarm. So this digital alarm will trigger if any of these inputs come on, and will give me a signal fault alarm just to warn the operator that there's something wrong with that signal. Okay, so then we've parameterized basically everything we can in Aorus Logics. So now we can just go and export this routine to an L5K file, or L5X file actually. Okay, let me export it as peak tag name P. There's already another one, it's fine, I'm just going to overwrite it. Okay, so now I can start gener8, create a new project, go straight to the L5X editor and import my L5X, which was p tag name P. So now it gets all of this into a nice text version, which might be a bit hard to read, but we added some tools here to format it nicely and make it a bit easier to navigate through all of this text. So there's this auto format XML button which you can click and it will tab it a bit according to the hierarchy that we're using. And here is a collapse all. So now I can just roll down and you'll see this is quite similar to the tree that you see in Aorus Logics. Here you'll have your data types, you'll have your add-on instructions, your tasks, your programs, and that's pretty much the same which you'll see here. Your data types, add-on instructions, tags, programs. Inside your program you've got routines. If you would have had program scope tags, then you would see a tags folder inside this program. I can drill down into my routine, can actually see what's going on. I can actually go and have a look at my function block content. There's several sheets, in this case only one, and all the objects placed on there and the references and so it's not too bad to read when we're using this expand method here. So let's first go and just scan for whatever tags we can get. Actually, before we do that, there's some more information that I would try to get as parameters, and that would be on the scale block, my raw maximum minimum, which typically would be milliamps, 4 to 20 milliamps, and the maximum, which could be anything depending on the instrument. I would like to have that as parameters as well. Now I can't type it in here, but here in gener8 I already configured a detection template to do that. So if you go here on parameter detection templates, I created a detection template here, which is, let me just find it here. I have it for scale in raw max, in raw min, should be a little up here. In raw min, in raw max. Let's make the in raw min the default value 4 milliamps, which makes more sense. So this detection template, it scans here through this XML until it finds something that starts with tags, and then it will start looking for something that only starts with tag. So it will browse in here until it finds tags, then it will start looking for something that starts with a tag, and then it will start looking for something that's got this data type scale. So it will, inside any tag, it will find something that's got a data type scale, and then it will look inside the structure and until it finds the next step, which is name in raw min and data type. So this should be a unique string that it won't, otherwise it might like replace all the values with this parameter name. So it will in this case look at in raw max or in raw min, the string right up to, from in raw min right up to there, and if it finds that, it will replace whatever's inside up unto what is the last step, and that is the ending quote, up to that quote, and we'll replace it with a parameter name with a p underscore name underscore p in there. So this saves a lot of time. If you have your detection template set up, you can instead of going and manually entering parameter names here, with a single click you'll have all of that set up. can easily create your own. You can duplicate one of the existing ones. These are actually ones I built myself, but there are some detection templates built in, like for example some alarm severities and conditions. On the analog alarms, you've got your high, low enables, and limits and severities, as well as a dead band and a minimum duration. That's all part of the standard detection templates that comes with gener8 Studio, but you can very easily create your own. Okay, so I'm going to close this, and I'm going to click on scan for parameters, and now I'm going to say I want to have my analog alarm enables. I would like to have the limits, all of that I would like to have as parameters, and feed all that data from Excel into gener8. Minimum duration and dead band I would like to have. Here's some other custom stuff I built at a stage. Here's my scale. There we have them. Okay, and this cleanup template, it just cleans out the binary data, the section here. See, with each when you export, it exports the data both in binary format as well as in a text format. We want to strip out the binary data, that it shouldn't interfere with our import. Let's go to scan. It remembers my tick boxes, so I don't have to tick them again. And I'm going to say scan XML. And here it built me a parameter list. It's quite a few parameters, so you can go into quite a bit of details on when you import and export. I can reorder this a bit. For example, I can move the tag name to the top by clicking this up button. Goes a little bit slow here on my side. This screen recording software is slowing it slightly, but in this way you can order it the way you like. So we have to set up all the detected parameters. Parameters detected by detection templates. If you have a look at your detection templates here you set the data type and the default value. But parameters you set in or you created in RSLogix, those you will have to configure here now. The tag name should be a ControlLogix tag or name object. You can see a little description here on the side. These alarm enables, these were all set up, all the alarming settings were set up with a detection template, so they should be fine. And the description, that should actually be a string type. The display, that can be string type. Display name in factory.view is not so limited. The area, you see I had a little typo there, but that's fine. This is a parameter name, but this is actually the column name I'll be using in my main window in gener8, so let me just fix it here. Area and area description. So area is actually going to be a tag, but the area description is a description that can be string. The name can be a string, the unit is a string, the raw unit's also a string. Model fault, that's going to be a tag, but the description can be string value. The rack, that's actually going to be a name. That's either local if it's in the local rack, or it's going to be the name of the comms module in the remote rack. Slot is going to be an integer, so make it a dent, and the channel is also going to be an integer. Here I can assign default values. If it's a template that I'm going to use often, then I can actually put some nice defaults here that I normally use, and also some descriptions. For example, tag name used in Logix, whatever. You can put your own descriptions there. Okay, so then we're done with this. I can close this window as well, and then in my main window, all those parameter, not the parameter names themselves, but the name here. These are mapping to the column names. The identifiers are mapping to whatever you'll see inside of your L5X editor. So let's close all of this. Okay, so now here obviously I can create rows here and do all of this manually, but I already have quite a bit of data in an Excel sheet, so I'm rather going to use that. So here's my Excel sheet. So all of these in your Excel sheet, the first row has to be the headings that you're gonna import, and after that you have your data. So that's the only restriction in your Excel file. It should have something in the top column, otherwise it will give you column numbers like an F1, F2 or something like that, which is not going to be very user friendly. So if you build your Excel file, just have some other descriptive headings. Now here we go import, and I'm going to, let me just see what this file name was, AI. So it was this AI file. Now you'll see here, if you select your sheet, it will automatically map columns to Excel column, or Excel columns to your Gener8 Studio columns if the names are matching. But here we see in Excel I've got an ALM-AI enable where it was enabled in Gener8 Studio. So now I have to map these manually. So obviously if you have them exactly the same, then you'll save a bit of time not having to map. Again, the scales, I think in Excel I had it without the scale prefix. Let's just find them in raw min, in raw max, in engineering unit min, and in engineering unit max. The display, FTV display, that's what we had there. The name, I had it as a display name in Excel, and the unit, I think it just was a unit, and the Unitroid mapped. Model fault or something else, model fault and model fault description, no, model fault description. And then we have all of them mapped. If you don't have a column in Excel but you have it in Gener8, it will use the default values. So, oh, there's some problem here. Couldn't store in the unit raw. Expected type is single. Oh, the problem here is actually that I didn't set up my unit column correctly. So let me quickly go and fix that. So if I go to my parameters and I just find my unit raw, see that's a real, that should have been a string. That's why that happened. Okay, then we'll just have to quickly go and remap those before we can import. Let's just test it whether it's working now. So it was my unit PV didn't want to work. Let's do a preview. Okay, it's happy with that. Hi. It was in raw min, in raw max, engineering unit min, engineering unit max. And this was the factory top view display that I had somewhere there. Here it is. Display name, model fault, and model fault description. Okay, so it's happy with that. Okay, let's do an import. So here I've got quite a few instruments, and all with their alarm settings and alarm limits and dead bands and the scale values and all of that. So now I can save my project if I want to reuse this later on. Let's save it as demo and export. I would like to export all of this into one program, and so I can say combine routines to program. Let's call this analogs, and let it create a main routine for me. Then I don't have to go and build all those jump subroutines myself. Okay, let's call this demo. And yeah, I already have an RSLogix program open with the IO cards assigned. So you'll see in this Excel sheet here, I already had rack slot and channels, always in the local rack, slot 1, slot 2. So these I already added into the IO tree here. Okay, let's go into my main task and say import program. And select demo. Okay, so here we'll see there's no program tags, but controller scope tags are here. This is all the tags it will create, each of them with their names, descriptions, all of that according to the parameters we created. Some add-on instructions, it will import them, and my UDTs will import them as well. So I can just say okay. Yeah. You can actually do this online as well while your controller is running, which is very handy. So you can either import individual routines or programs. So if you do some additions to an existing system, it's very useful to be able to use these tools even though it's a live system. So there we go. If we check our main routine, there's all my jump subroutines, and if I open any of these ones here, I can do some checks. It's hooked up all the IO. Let's check the string values in here, and there it import these. And on my alarm, it should have set the alarm limits, the enables, the display command that I entered there. So that's how you do it with function block routines. You can use it with ladder and structured text just in the same way. So that was just to show you how to do it with function blocks. This is the end of this demonstration. Thank you very much for watching.